My name is Nithin Kavi. My project is called Cutting and Gluing Surfaces. I did it as part of the MIT Primes program under the mentorship of Zenkun Lee. My project was about using combinatorics to analyze the grading of a sutured monopole floor homology of a sutured manifold. The sutured monopole floor homology is an associated abelian group or vector space to the sutured manifold, and this vector space can be decomposed into a direct sum where each summand has an associated integer, and these integers form a z grading. My project was about determining whether or not this grading is well defined. To do this, we look at surfaces embedded within the manifold and also translate this problem from topology into combinatorics. When this happens, we begin with a surface S with one boundary component, which we represent as a disk here. On this boundary component, we have two n vertices labeled P1, P2 up through P2n, where the arcs between adjacent vertices are alternately labeled plus or minus. Then we attach strips, where one side is labeled plus, one side is labeled minus. In doing so, we have the strips, we have the arcs along the boundary component, and these form positive and negative boundary components, as shown. We say that a pairing is balanced if it has the same number of positive and negative boundary components. We can relate these balanced pairings through cut and glue operations or topological surgeries. Anytime two balanced pairings are connected through a sequence of these cut and glue operations, they induce the same grading. So if all the balanced pairings are connected, then they all induce the same grading on the sutured monopole floor homology, which means that the grading is well defined. To prove whether or not this is the case, we can look at two examples. So in figure 1 here, we have the original disk and two strips attached which overlap. The disk, together with these two strips, forms another surface with one connected boundary. And this means that we can look at a similar problem, but now we have 4 fewer vertices, and this allows us to use induction. On the right, in figure 2, we have a similar case, where we have the original disk, one positive boundary component, and one negative boundary component. If we imagine pulling out those two strips and those 4 vertices, then once again, we end up with a balanced pairing with fewer vertices, and we can use induction. Together, this means that we have that for a surface with one connected boundary induces a well-defined grading on the sutured monopole floor homology. We could generalize this to surfaces with multiple boundary components, as shown, and we use a similar tactic where we look at two surfaces or two boundary components connected with one strip, and together those form a surface with a single boundary component, once again allowing us to collapse to a smaller case and use induction. This result and by doing so, we get that the grading is well defined even when the original surface has multiple boundary components. This result that the grading is well defined has been cited by my mentor and a Harvard PhD student. So I could not have done this by myself, so I would like to thank my mentor Zenkun Lee, the Primes head mentor, Dr. Tanya Kavanova, the MIT Primes program, and the Regeneron Science Talent Search for giving me the opportunity to present this research. Thank you.